All right, in this class, we'll cover quadratic functions as stated. And yeah, the questions which we have, um, of course, I have not tried any of them. So we'll try them and work them out together. And I'll explain most of the concepts even as we go on. So generally, a quadratic function is given in the form f of x, where you have a squared minus plus bx plus c. So you have to have a mathematical expression that has constants. So the constants are a, b, and c. And one of them, a, has a variable of x squared. Then b has to have an x term, and c has to just be a constant without any variable. So that's what you have to have. And the other thing that you must notice from here is that when we're dealing with such a function, so in our case, we want to be able to, first of all, complete the square on it. And second, you want to be able to graph this function. So I'll not look at the general way or the general form of the quadratic function. I know you know it by now, but we'll use those steps, and I'll try for the first one to take it step by step that you understand exactly how we are able to graph. Okay, so you have a function f of x. The first one is function f of x. You have 2x plus 8x minus 3. So if you have this, how are you going to factorize? So when it comes to factorizing this, you first have to make sure that you factor out your x. Okay, so I can I can actually do it first on this one. Maybe it won't be too much to check out the general one as well. So where we say you factor out that a, and such that you remain with what? With, you have your x squared, there you remain, then there you just have what? B over what? B over a, like that. B over a, you have b over a. So you have b over ax, then you have a plus. See there, you can also factor out the what? The a there, like that. So now, how is this going to be? From there, what you want is, you want to get, so you write your x squared, then you half and square this. So we say this b over a x, then the coefficient of what? Over coefficient of b over a, you have, and what? And add that. So now you have to, yeah, have, so the negative and the positive. So by adding, so first of all, we're saying we add. So you're going to add like that. And this here is going to give you, so half of this. So that will be multiplying by half. So you have b over what? To a. So you're just doing this to the coefficient like that. Then minus b over what? To a, like that. So squared. Okay. So this is what you're going to watch. This is what you're going to get. Then the other part is just plus what? Plus c over a. And you see that this here, you have your a. Then what you do, this is a big bracket, small bracket here. You get now x, one of the x. Then here you get this one, the one you have, one of them. Inside, what is inside? Not the square, of course. Then when you get that, that will be plus b over what? To a, like this. Then you square it outside there. Then you have a minus. So minus whatever this, the way it remains just like that, which is going to be b squared over what? Over 4a, 4a what? 4a squared. So you have something like this. Then you have a plus plus what? Plus C over A, like that. Okay, so then you can multiply your A throughout. Then you just have your A at the first one, which is A plus. Yes.
What is that? Minus b squared over 4a.
Coming from? Okay, so
Yeah.
here where you have the second square here with a negative sign, see this one? You have to square, you have to evaluate this one. So this first part, this one here, up to here, you can see this up to here. We've accounted for it, which is this part here. So when you expand this here, which is x plus b over 2a, you expect to get this x squared plus b over a plus this entire thing, which is here. So yeah, that's what you expect to what to get. Okay, so then, which means we remain with what? We remain with this part, which is negative what? Negative b, then negative, then you have a b over 2a squared, then plus c over what? C over a. So now this we just evaluate, we evaluate it, we square this, so we are squaring b, so it will be b squared. Square what's down, so you have 4, since it will be 2 squared is 4, then you have a squared, then plus c over a, so that's why you get that. Then which leads us to this one, you multiply the a, then you have this, so b over, okay, that right. So you have a b over what to a, then you have a squared there. So this here, which is squared here, when you expand this, you expect to get this thing here, which is there. Okay, then I multiply a, multiply this side here, I remain with b squared over 4a. One of the what? This square cancels with what? With the a there. Then I multiply it with this part, then I just remain with what? With c. Just remain with c. Then I say a there to b squared plus b over 2a, making this into a single fraction. What do I get? So down there it's before a, then you have b squared, then that will be plus what? Plus 4ac, like that. Okay, I said we won't drive it, but I found myself driving it. But yeah, it's important to understand where it's coming from. Then when you multiply the negative, you have a over x plus b over 2a squared. Then you multiply that negative. So when you multiply the negative, of course, this here will become positive. Okay, I can choose it to be like this, or I can write it the other way around, where I say I want my 4 to start. So, like this. So, this here will be negative, because if I multiply that negative, is it like that? So I multiply positive, that would be negative, negative. Okay, what did I say? 4 minus, okay, minus b squared over 4a, yeah, over 4a, something like that. Or you can just leave it here, really. That's not really a problem, yeah. You can leave it there, it's okay, here at this stage, just like that. It's fine. So this would be the complete stage, really, after completing the square. So you'd get this. So that's kind of what we work with. So I'll write it here for the sake of just keeping it, that we'll be able to relate as we go on. Squared, then you have a b squared, then plus 4ac, number 4a. Okay, so from here now, how are we going to do this? So here we can start. So the first step, we want to factor out the 2. So when I factor out the 2, I remain with what? X squared here. Then I have here 2 divided into 8, I'll have 4. Then x, then 2 divided into that negative 3, I just get negative 3 over 2, like that. Then I have 2. I can now factor out this. So x squared, I'll write it in full for now, but going on forth, I'll be leaving out the steps. So that will be plus 4x. So I add half of this. What's half of 4 is 2. Then I square 2. Then I subtract again. Then I square it. Then minus 3 over what? Over 2. 2 like that. Then I have x squared. Okay, so I leave out the square now. So I write it like this. X, so I get the x. Then I get this here. That will be plus. Then what's inside is what is 2. Then I square it like that. So when I expand this, I'll get what's here. Actually, you can do that and you get what's here. Okay, then you bring minus there. Then what when you square this, what you get 4 minus 3 over what? Over 2. Okay, so from there, uh, you multiply 2x plus 2 squared, and you can multiply this 2 by the 4, you get negative 8. Multiply the 2 by 3 over 2, you get negative 3. And this will just simplify, so be equal to 2x plus 2 over x squared. Then you just add these two, you get negative 11. So you have what? You factorized it completely. Okay. Now, after factorizing, we just don't want to end there. We also want to be able to sketch our graph. So how will we sketch this graph? So what you need when you're sketching this graph is you need what are called your intercepts. Intercepts, number one, and that is your x-intercept and your what? Your y-intercept. These are what you need. Number two, you need what you call your turning points. Turning what? Points. In this case, because it's a quadratic function, it only has one turning point. So you need that turning point. And yeah, that's the only thing that you need to have about what to graph. Okay, and the other knowledge that you need is to understand where your graph is going towards to face. So when the value of a here, so when a is greater than 0, which means a is positive, my graph will face the what? Positive direction, which is the upward. It will have a smile. It will have a what? A smile like this, facing upwards. Then, not only that, you can notice from this that your turning point, which is that point where it tends. So you see that it's going like this, then as it reaches that point, it changes direction and starts going up like that. So that point is called the turning point. And that turning point, because of this mark, you see that it is down. So it's called a minimum turning point. Minimum turning point. Okay, so that's what you need to understand. So in our case, our A is what is positive, as you can see. So we know it will have a minimum turning point and our graph will face upwards. How do we find these intercepts? So the intercepts, remember, this is f of x or y, f of x, this will factorize to this. So the intercepts, the x-intercepts are found when the value of what of y is 0. So this function where we ended say this is y like that minus 11, and we're saying when this is 0, that's when you can find the intercept. So I'll equate this to 0 minus 11 equal to 0. And what am I going to have? I'll have 2 plus 2 squared. This will give me 11 this side. Then I can divide by 2. So when I divide by 2, I just remain with x plus 2 squared 11 over what? Over 2. I can get the square root on both sides. Then I just have what? X plus 2 is equal to plus minus what? You have this here. I cannot simplify this without using a calculator, so I just leave it the way it is. Then what else do I have there? I take the negative other side, I get negative 2 plus minus root 11 over what? Over 2. Okay, what does that now tell me? That tells me that I have two values. So the first value of x, so I'll write them here. Value of x, that's when it's negative. You have negative 2 minus, let's say we subtract first, then you have 11 over 2. Then the other value of x is going to be negative 2 plus root 11 over what? Over 2. Okay, so those are going to be your what? Your x turning points. Then what else do you need? You need your y turning point, and your y turning point is the point when what? Uh, the point when x is equal to what? X is equal to 0. So when x in that function, the original function there, you see, just make x equal to what? That's your intercept, of course, not your turning point. I mean, x equal to 0. You plug in that here, you get 0 and minus 3, and this will just give you negative 3. So negative 3, y equal to negative 3 is your what? Your y-intercept. Then you now want your turning points. So your turning points are given exactly by this value, which is here, this value, and this value which you see inside, this one is b over 2a, which is also the line of symmetry, but multiplied by a negative. So you always have to multiply this by a negative. So here we have 2, so we multiply it by a negative, we end up with negative 2. Then we get the negative 11 the way it is. So our turning point is negative 2. Then here, negative what? Negative 11, like that. So this is going to be our turning point. So we have what we need to graph. We can graph now. So sketch like that. So negative 2. So let's say negative 2 is here. It's going all the way. Let's say negative 11 is there. So this here is going to be my what? My turning point. So y cuts through negative 3. So it will go like this. Wherever there. Then it will also go this way, like that. Pardon my graph, but it will look something like that. So this point here where it's turned, that's our negative 2, comma negative 1. Here where it's cut, that's our negative 3. Here where it's cut, which one is bigger between these two? This here gives us a negative number, so that one should be the negative 2, negative 11 over 3. Then that one should be negative 2 plus root 11 over what? Over 2. So that's how you get your what? Your graph. And that's how you you would sketch your graph. Okay. Unless there's any question on how we sketch our graphs and how we obtain what to sketch. Are we clear?
No, I'm following. I'm following.
Okay. So I asked we do one question which involves the negative, such that you look at the inverted one. As you can see, I'm really struggling with my voice right now. But yeah, we do that one. Then we'll move on to the next part, which just also involves solving the equations, not the functions, but just equations now. Okay. Okay, so we choose this one, F. I have not tried, it's random choosing. Negative 2x squared plus 12x minus 5. So now what do we do? Let's factor out the negative. So here our a has a negative 2, which must tell us something about our graph, which is, if you're following me, if it's negative, what will that mean?
The graph will face downward.
Okay, our graph is going to face downwards. Yeah, right. So we have a graph that will look like this, and it will have what we call a maximum turning point. Not only will it have a maximum turning point, but it will face what? It will face down as well. Okay, so here we continue. Factor out a negative 2. There we will have negative 6x. Then there we will have a plus 5 over what? Over 2. Okay, so as I said, I'll leave out the steps, some of them. So here negative 2. I just go directly here, get my x. I have this negative 6. When I have the negative 6, I get negative 3. Then I square that like that. Then minus. So what's the square of, when I square negative 3, I get what? Positive 9. So I put the 9 there. Then I get the plus 5 over what? Over 2. Then I can multiply this here. So when I multiply that, what do I get? Multiply negative 2. So here we have negative 2x minus 3 squared. There to be plus 18. There to just give me a negative what? Negative 5. That will come like that. Okay, then I get negative 2. Then x minus 3 squared. Subtract this. You get 18, is it? Okay, so you get a 13 like that. What do you need? You need your intercepts, you need your what? Your turning points. Okay, so saying here we then need our intercepts. So our x-intercepts will be obtained by equating this to 0. Get negative 2x minus 3 squared plus 13 equal to 0. And you get, because the other side becomes negative and divide by the 2 becomes positive, and you have a 13 over 2. Okay, then introduce your root here and your root there. This one looks like these questions were not giving perfect verses, but anyway, that is well. X minus 3 is equal to plus minus, then root 13 over 2, then you have x, then you have a 3 plus minus root 13 over what? Over 2. Okay, then that is going to give us, of course, you have 1, which will be, when you add, which will be in the positive region. This one, other value of x is just going to be 3 minus root 13 over what? Over 2. So this is what we will get. And okay, that's what we'll get. So I want to move that up here. Um, okay. Okay, I keep those there. Then I will erase. What do I need? I also need my y-intercept. Of course, my y-intercept is easy to obtain. When x is 0 here in the main equation, you can see that your y is going to be negative 5. Turning points can be gotten from here. So negative 3, multiply that with a negative sign, you get positive 3 and positive 13, which is tallies with what we said in the beginning, that we have a maximum turning point. So it has to be positive in that, or it has to be in the positive region, as there we've seen. So I can now draw my graph like that. Okay, so where is this going to be cutting? So I have that. I found my y to be negative 5, so I need to cut somewhere there, and yeah, they have a 3, 13. So I want to say if my 3 is here and my 18, I don't know, somewhere there, this will come and just to cut somewhere like that, and that's why I did to cut like that. Then this is your graph y there, that's going to be a 3, 13. That's your -5, and these are those points which we are up there. The first one, which is the 3 minus root 13/2. Then this one is 3 plus this point here, 3 plus root 13/2. Okay, so that's how you sketch, and that's how you complete the square, unless there are any questions. Generally, that's how you do it. Are we together?
Okay, yeah. Mm-hmm.
All right, so lastly, we do these questions, which are basically the same. So just walk you through one of them. You can choose which one we can do.
What
Uh,
D?
B,
D.
D, okay. So kind of the same. Actually, let's make it more interesting. Um, Instead of us going that route, since we already understand that from the way we were doing when finding the intercepts, to solve this equal to 0, first of all, you can use any method out of the 3 that are common. That is, factor method. You look for factors and you factorize, and can use the formula, which is x equal to -b plus minus root b squared minus 4ac, then divided by 2a. Or you can use the way we were doing, you complete the square, then you equate it to 0, then you find your values. Now, we're gonna make it more interesting by putting or introducing an inequality. So I'll get this one, though it can be complicated, but okay. I don't know if it's a complicated one or not, but we say we want this to be either greater than 0, we use inequality, greater than 0 or less than 0. It might fail because the question is not tested for that. Okay, but now what are we going to do? So when you have something like this, it means that in your solution, what you're looking for is strictly where to be greater than 0. It cannot equal to what? To 0. If there's an equal to, then you want an equal to be what? To be there. So remember, as we are doing in the case for those cubic ones, it's the same. You first factorize. So factorize here, complete the square. So it will be x minus 1 squared minus 1. Then you have a what? Minus 11 greater than 0. Then you have a x minus 1 squared minus what? 12. So you look at this, you want to factorize that nicely. So okay, so you have that, and minus 12 equal to 0. Taking that the other side, you have x minus 2. Or first, even you can check if this has factors. These are factors. -11 when you multiply, okay, when you add -2. Nah, I don't think they are factors. Yeah, as I said, this question is not initially designed for that. So I look at it to be going to be very complicated, but take it like that, take that side, you have your x minus 2, then plus minus, here it's 4/6, so 2 can come out and I have 2 root 6 there. Then you have x to be equal to 2 plus minus 2 root 6. So you have, what do you have? You have x being equal to 2 plus 2 root 6. Then you have x equal to 2 minus 2 root what? Root 6. Okay. So these are going to be factors, linear factors of the form 2x minus 2 uh, minus 2 root 6 like this. Then the other one is going to be 2 minus 2 plus 2. Okay, I forgot the x. So it's going to be x minus 2 plus 2 root 6. So these will be your linear factors when you complete this or when you factorize this here. So saying here what you're going to have are these, which is x minus 2 minus 2 root 6, then x minus 2 plus 2 root 6, like this, greater than 0. So you want to look at which point is greater than 0. Of course, you found this, you found this. This is very complicated, really. It's going to be very complicated. But let's imagine away from this, for the sake of explaining, I know you do the questions that are related or designed for that. Let's imagine we had factors that are very simple, x plus 2 like this greater than 0. So this means you had x values that's 1 and x values negative what 2. Those are your what you call your critical values. Then using the table as we were doing before, you can what plug them into your table where you have your x minus 1 and you have your x plus 2. Then the last one is x minus 1, x plus 2, like that. Then remember here -2. Then there you have your 1. So here there are values of x less than -2. Here values of x between -2 and 1. Then here x is greater than 1. So pick out a value less than -2. Let's say -3. You plug it in there, you get a negative. Plug it in here, you get also a negative. But negative by negative gives you a positive. Here in between, so let's say 0. We put 0 there, you get a negative. Put 0 there, you get a positive. Multiply these two, you get a negative value. You get a negative value. Here, greater than 0, let's say we say 2, get a positive, you get a positive. Positive by positive gives you a positive. And they usually tell you to write your what? This in interval notation, to write your solution set in interval notation. So what are we looking for? Greater than here. So this here and there are the greater than what portion of it. We should not get 0 at what? At all. You should not get 0 at all. That's what I'm saying. So greater than, so this and this. So how do I write my solution set? Is just going to be there. It's from -infinity to what? -2. It will be open because I don't want it to be equal to, since that's what they're telling me, union. And the other side will be 1 to infinity, like that. So this here will be my solution set. So that's how you do it. So you can try the rest. I'm sure even from those, that concept we first did with the cubic ones, I'm sure it explains it. This is the easier version of it. Unless there are any questions, but this is how you do it. Yeah, they will not really give you ones that are going to be complicated. Like these ones here are meant for you to find answers or solution of X like we did, not for you to be finding this kind of work like this. Unless there's any question.